Hey there, welcome to this lecture. So for the past several lectures, you were learning about object orientation, and we were going over creating our own types. You created the animal class and the bird class, and we talked about interfaces and abstract classes, and that's crucial information for the remainder of your experience in Java, okay? And so in this lecture, I want to talk about a special type, which is known as the string. Okay, it's a data type that you'll be using all the time. Data types such as the int or the boolean or double, float, long, they're so commonly used in the Java programming language, and it's easy to think about the string data type as a similar kind of a data type, but that is absolutely incorrect. The int, the double, the float, the boolean, the long, they're primitive data types, but the string is often confused to also be primitive, whereas it's not a built-in keyword such as the int keyword or the boolean keyword. The string is actually backed by a class definition. The specification of what a string is and what it's supposed to do, the different methods, those are all defined in the string class. When I print something to the screen, let's say a sentence or whatever, it's actually creating a string object in that process. And it's basically an instance of the string class. So we're going to go over that in this lecture. We're going to talk about some of the things you can do with strings and some parsing methods that will prove helpful in your Java programming experience. So let's get started on that. Here I've created a project already called Prereq Practice, and you can name these projects anything you want. As you move on through this course, I create projects and I expect you to just follow along and create them on your own. And I've created a class here called Strings Practice, and you'll notice that right now I've got the JRE 1.7 loaded up. So whether you're using 1.9, 1.8, 1.6, the things that I cover in this lecture are going to be essentially the same across all these different Java versions. At the time I recorded this lecture, I was using a different mic, so I apologize if the sound quality deteriorates a bit, but let's move on to learning about strings right now. So here we have a string object variable called a, and it stores the value hello. So let me show you how to get the length of this string by calling a.length. And what this is going to do is print out the number of characters in this string. And notice that it printed out 5. And the reason for that is a string is basically a sequence of characters. So 1, 2, 3, 4, 5 characters. And if we put spaces inside of this string, each one of these spaces also qualify as characters. And this .length function is going to give us those additional characters in the length. So let me play this again, and notice that now the a variable stores a string that is 8 characters long. All right, and there can be all types of random things in here, and each one of these guys is going to qualify as a particular character. And if we play that, notice that it's now 20 characters within the string. Take a look at this diagram. This is what a string looks like in the memory of a computer. So every single character of a string is actually associated with a particular index. And this just provides a way for us to be able to access each and every single one of these individual characters without actually referring to the letter or the character. We can access it using this index value 0, 1, 2, 3, 4, 5. So to be able to access parts of this string, we have to reference these index values. So let me show you how this works. Let's go back into Eclipse, and I'm going to define a new variable. I'll just call it str. And I'm going to assign it A, B, C, D, E, F, G. Okay? Now, this particular variable has a string with 7 characters, right? 1, 2, 3, 4, 5, 6, 7, okay? But if you recall, according to our diagram, the first character of a string, its index value is 0, and the next character's index value is 1, and so on, all the way up to the last character's index value, which is going to be the length of this string minus 1. Okay, so let me show you an example so it makes a bit more sense. So the method we use to extract parts of a string is called the substring method, and the way you it's the same thing like we did for str.length, right? This is a method that we call on the string, and remember, methods in programming languages do things. So when we do this, it basically is going to return the length of this string, which is, remember, 7 characters long. If you count that up from 1, 2, 3, 4, 5, that's 7 characters. But the index values of each one of these characters is 0, 1, 2, 3, 4, and the last character here is G, is actually with an index value of 6. Okay, so based on the index values, now that we know that the first character in a string is 0 and the last character of the string is going to be the string's length minus 1, let's try to use this substring method to pull parts of the string out. And the way this works is we give this substring method an argument. All right, so when we give it 1, okay, I'm just going to create another variable here called string, and I'm going to name it extracted string. Okay, put a little space there. So I'm saying of this string, extract out, well, you'll see exactly what this extracted string's value is. So let me actually print that here. Notice what it did. It skipped printing out the first character. Now let's give this substring a value of 2. Notice that it skipped the first 2 characters. Okay, so what's going on here is substring 2 is actually referencing the index value 2. All right, and if we go back to our diagram, notice that if we have substring 1, it references index 1 and then prints out the rest of the string. If we do a substring 3, it goes to the index value 3 of the string and prints out the rest of the string. Okay, and then if we do a substring 6, which is the last index value of of the character, and that's G, that's all it's going to print out. So we can basically extract parts of this string using the substring method, and in this case it accepts 1 parameter, but there is a way to extract using 2 parameters. What if we want basically a part of this string that doesn't go all the way to the end? We only want, let's say, for example, B, C, D, or C, D, E, or D, E, F, instead of from B all the way to G, or D all the way to G and G itself. And the way to do that is you pass 2 arguments to the substring method. Take a look at this diagram. Let's cover the first example. Notice that we're passing 2 arguments to the substring method. The first argument is, you've already seen this, is the starting point for where you want to begin extracting the string. So we're passing in the 0th index, so that's going to give us A. And then the second argument is up to, okay? And in this case, we're passing in the index 2, which happens to be C. But in the substring method, the second argument is non-inclusive. So what that means is we go from 0 to the second index, or the index number 2, but not including 2. So what that gives us is A and B. When you look at this next example, here the starting point is index 1, which is B, and then we go up to, but not including the character in the index 3. All right, so what that gives us is just between 1 and 3, which is just B and C. And then the third example, we start from the third index, and then we go up to, but not including the character at index number 6, okay? And that, of course, gives us D, E, F. So you're beginning to see the pattern here. And in the beginning, it might be a little tricky for you to pick this up, but with a little bit of practice, if you haven't seen this before, it'll be much, much easier as you practice this stuff. So let's look at the final example. We start from index number 3, which is the character D, and then we go up to 7, okay? And that is taking us all the way down past the 6th index. So this doesn't fail because we are following the rule. The second argument is up to, but not including. Okay, so that's why it's just going to take us from D to G, and that's what we have there. Let's go back into Eclipse and learn some other things about strings. Let's define two variables, and they're going to be of type string. I'm going to say string A is equal to hello, and string B, its value is going to be there, for example, okay? Now, if we want to check for whether A is equal to the string hello, and if you didn't know about strings, or if you're coming from a different language, you may use the comparison operator as A, if A is equal to hello, right? And this is a trap. Don't do this, right? The correct way to compare strings is we have to do A dot equals, there's a method on the string object, equals, and we do hello. Okay, so in this course, when we're comparing strings, we want to use this, okay? So stay away from comparing strings like this, okay? It works with integers, it works with characters, and the difference is the string is actually an object, whereas the other data types, such as integer and Boolean and so on, those are primitives. The string data type is actually backed by a class, and that's why we refer to string variables as objects, but don't worry about those details for now. That's something we're going to discuss in great detail later on in the course when we talk about object-oriented programming. Just keep in mind that when you're comparing strings, you want to use the equals. And of course, I talked to you about the not. And if you want to check for whether A is not equal to hello, all you have to do is just put a bang right before the A dot equals here, and that will basically check for whether A is not equal to hello, right? Or basically A dot equals is not, okay? So the way I read this is not A dot equals. So keep that in mind. This is a trap. Don't compare strings using the equal, use the dot equals. Let me show you something else. If B, which contains the value there, if B equals there, okay, then we want to do something. Let's just print out something. Printed there, okay? And when we run, you'll notice that this runs, okay? But we can also check for whether B dot equals there with a capital T, all right? And in this case, we do not expect this printed there to run. So when we play this, notice that nothing got printed because we're comparing the value that's in the variable B, which has a lowercase t, with the string there with a capital T. So to pass this condition, we can use this method called equals ignore case. Okay, and in that case, this will work fine. All right, we can have other characters in here that are all capital, right? As long as it's spelled the same, equals ignore case will work fine. All right, just like that. All right, so let me show you a few other things we can do with strings. Let me get rid of all of this to make some room. To be able to figure out what character lies in a particular index value of a string, we use this method called char@. So we can say a.char@, right here, this is the method, and notice the definition. It accepts an integer, so we can say, let's see what character lies in index number 3. Okay, so again, remember it starts from 0, so H is 0, E is 1, L is 2, L is 3, okay? So it's going to get the second L here, which is at index number 3. And we could just basically print this out. And I'm just going to surround a print statement in here. And hit play, and notice that it did, in fact, print out the second L. All right, let's see what's in 4. And it's O. And oftentimes, if a string is really long and you need to figure out, if you're doing something programmatically and you want to be able to figure out the index value of a particular character within that string, this method is pretty handy. Now notice if I give a number that's way too large for this. Let's say if I say 13, right? We know that this particular string is not going to have a character at the index position 13, right? So let's hit play and notice what happens. It says string index out of range, okay? So it does not accept that. If we try to give it a negative value, let's say -1, hit play, that's not going to work either. By the way, the reason I showed you this negative index example is because some languages, such as Python and Ruby, do support this sort of behavior where you put in a negative index value and basically it starts at the end of the string and works its way back. But in Java, this is not how you do it. So I just wanted to clarify that for those of you that are coming from different programming language backgrounds. Now, one thing I want to bring up about the char at method is that this method returns a data type, and that is the char. It's similar to the string in that you can store different types of text in there, but it has to only be a single character, okay? And you surround it with these single quotes instead of double quotes as you would with strings. And the reason why it's available to us in Java is that it's much more efficient to deal with single characters using this char data type. We'll be revisiting this data type later on in some of the puzzles. But anyway, let's move on to some other handy methods in strings. The next handy method we're looking at for manipulating strings is called the index of method. And this method basically gets applied on a string to search it for a specific string value. So we pass this method a string argument, and it basically searches for that string. And the way it does this is it searches from left to right, and it returns the index number where that target string first occurs. So let me show you an example of this. So let me get rid of this stuff. Okay, so I've defined the string, hello there, Yogi. And what I'm going to do is I'm going to figure out where the word there occurs in this string. So we can do this, str, right? That's the string variable. We apply the index of method and notice that it accepts, well, there's a couple of things that you can pass into it, but we're going to go with the string example. It accepts a string. So let's select that, and then the string that we want to pass in here is the one that we're looking at, and we want to search for where there occurs within this str. And what it's going to do is it's going to return the index position for where it finds there first. And I'm going to assign that to a variable, let's just say the variable is a, okay? So we're assigning the index position where the word there is found to the variable a. All right, so let's print that so you can see where exactly it occurs. So when we play this, it starts at the index position 6, and you can count that from 0, 1, 2, 3, 4, 5, 6. Okay, that's where it begins. Now, if we had another there after Yogi, and if I was to search for, let's say 7, for example, this is the index position where we want the search to begin. Okay, and again, it searches from left to right. So index position of 7 would mean that we start at this H right here, and then we search forward. So let's hit play here, and notice that it did find there at the index position 17. Okay, so let's count where exactly it found it. So this is position 7, right? 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There it is. This is where it finds the next iteration of there. So again, when we put a 0 here, it will start all the way to the left, right? And it will find the first iteration of there, right, as it did here. And then if we pass in something that is beyond this point, it will basically search further in the string. Okay, so by default, there's always a 0, right? It always starts from the 0th index and searches from the left to right. If we pass in a particular value, it starts from that particular point onwards. Right? So keep this method in your mind when you're solving problems. It'll prove to be useful. Now, another thing you'll find yourself using is called the last index of method. And take a wild guess what this one does. Let's do this. B. I'm declaring a variable of type integer, and I'm going to apply the last index of method on it, on the string. And then the string that I'm searching for is, let's say I'm searching for Yogi. Take a guess what this does. Index of starts from left to right. Last index of starts from right to left. Okay, so in this case, we want to return the index position of the word Yogi in this string, starting from right to left. So it'll start from here. So let's hit play here. Okay, so we're printing the value of A. We actually need to print the value of B because we're searching for Yogi. So hit play now, and it printed a 12. So the position where it found Yogi first from the right side, searching from the right side to the left, that position is 12. So you can count from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is where Yogi is first found when searching from the right. All right, and I'll make a distinction here. Let me copy this Yogi and put it right after the hello here. And now if I search for Yogi using the index of method, right? This is the regular method. This searches from left to right. So let me actually also print the value of A here so you can see the comparison. Okay, so now we're printing both A and B. Hit the play button. And notice that when we search this string from the left to right, that is, this first occurrence of Yogi is found at index position 6. But when we use last index of, it searches from right to left. And the first occurrence it finds when searching in that direction is the word Yogi right here. All right, and that index position is 17. That's where it first finds the word Yogi searching from right to left. Most of problems can be solved just using index of and the substring method along with some char at. And you shouldn't have problem solving 90% of the problems out there. But if there is ever a need or you want to explore parsing a string using this last index of, it's available to you and you're free to use it.